For our last worksheet in our unit on radical expressions and equations, we're going to talk about rational exponents. And there's a few definitions we need to remind ourselves of. First of all, the set of rational numbers is a set of all numbers that can be expressed in the form a over b, where a and b are integers, and b is not equal to 0. That's just a fancy way of saying rational numbers are numbers that can be expressed as fractions. Now, rational numbers can also be expressed as decimals that terminate or repeat, but for us, we're interested in numbers that look like fractions, okay? Now, we mentioned integers. So remember, integers are the set of the whole numbers and then their negative counterparts. So no fractions, no decimals, just nice, pretty positive and negative whole numbers. And then we also talk about natural numbers, and I forgot to put the definition in here. So when you're talking about natural numbers, we sometimes call the natural numbers the counting numbers. They start at 1 and then increment by 1. So those are the natural numbers in case you forgot, okay? Now, the last thing we need to remind ourselves of won't actually come up till the end of the worksheet, but let's go ahead and remind ourselves of it now. We have the negative exponent rule, and it says if b is any number other than 0 and n is a natural number, then b to the negative n equals 1 over b to the positive n, and 1 over b to the negative n equals b to the positive n. Essentially, when you have a factor in an expression that has a negative exponent, it needs to change places in a fraction. So we could have something really simple like 3x to the negative second power over 4. Well, the 3 and the 4 are fine where they're at, but x to the negative second power needs to move. So we would move it to the denominator. So we would get 3 over 4 x to the second power. So that's all it means. We just take the factor with the negative exponent and move it. Okay? Now, for this video, we're going to focus on defining rational exponents of the form a to the 1 over n power. Okay, so here's the definition. If the nth root of a represents a real number, and n is greater than or equal to 2 and an integer, then the nth root of a equals a to the 1 over n power. So this denominator and this index are the same. And that is what you should notice. The denominator of the rational exponent is the index of the radical expression. Okay, so for example 1, it just says simplify. So let's practice. So we have 36 to the 1/2 power. That tells me the index is 2. And if the index is 2, you're dealing with a square root. So we have the square root of 36. So we're looking for one of two identical factors of 36. That would just be 6. 6 times 6 is 36. So that's it. So 36 to the 1/2 power is identical to the square root of 36, which is really just 6. Now, for part B, we have 27 to the 1/3 power. My denominator is 3, so that means I'm looking at a cube root. So I'm looking at a cube root of 27. Well, 27, we're looking for 3 identical factors of 27. And remember, 27 is really 3 times 9, but 9 is really 3 times 3, so that's my 3 identical factors right there. So we would say the cube root of 27 is 3. Therefore, 27 to the 1/3 power is 3. Okay? Now for part C, be careful. We do have the base in parentheses, so we have negative 64 in parentheses to the 1/3 power. My index is 3, so I'm looking at a cube root of negative 64. Since that negative is in parentheses and the rational exponent's on the outside, that means the negative goes under the radical too. And this is okay. When we're talking, my dog is outside losing her mind. When we're talking about nth roots, as long as the index is odd, the radicand and the result can be negative. So a cube root of a negative value is absolutely fine. So we're looking for our 3 identical factors of negative 64. Well, I know 64 can be 16 times 4, and 16 can be 4 times 4. So I've got my 4 identical factors, and because the radicand is negative, the result also needs to be negative. So I would say this is negative 4. So negative 64 in parentheses to the 1/3 power is negative 4. Now, again, we want to be really, really careful. Looking at part D, we have negative 9 to the 1/2 power. And what you need to notice here is the negative is not in parentheses with that 9. The exponent of 1/2 only applies to the 9, not the negative. This is really like saying we have negative 1 times 9 to the 1/2 power. So this is really like negative 1 times the square root of 9. Since my exponent has a denominator of 1, my exponent has a denominator of 2, my index needs to be 2. That's where we get the square root of 9. Well, the square root of 9 is just 3. So this equals -3. So what makes this possible is the fact that the negative is not in parentheses. If the negative was in parentheses, this would be a whole different story. In fact, let's look at part E. So in part E, we have -25 in parentheses, and that's raised to the 1/2 power. Since my denominator in the exponent is a 2, we need a square root. And because that negative is in parentheses with the 25, the negative is part of the radicand. So this is the square root of -25. And we cannot have this happen. When you're talking about a principal nth root, if the index is even, the radicand and the result have to be non-negative. We can't have a square root, and you don't generally write the 2, you just write the square root symbol without the 2. But if we have the square root of -25, that can't happen. We have to say that this is not a real number. So be really careful when the base is negative. Okay, when the base is negative, you're looking at parentheses or no parentheses. No parentheses, the negative stays outside. With parentheses, the negative has to go under the radical. So be especially careful when your denominator is even and you're dealing with a negative base. Okay?